This little guy is the horseshoe crab, a marine arthropod part of the family Lemulidae. Commonly used for bait and fertilizer, you will find the strange creature living in shallow ocean waters on soft sandy or muddy bottoms. The horseshoe crab is considered a living fossil, with the earliest fossils being found in strata from the late Ordovician period, roughly 450 million years ago. Its entire body is protected by a hard carapace. The crab has two compound lateral eyes, plus a pair of median eyes that detect both visible and UV light. Its mouth is located in the center of the legs, where their base has the same function as jaws, helping to grind up food, which primarily consists of worms and mollusks that they find on the ocean floor. It has 5 pairs of legs, each with a claw tip that enable it to walk, swim, and move food into the mouth. Book gills, which exchange respiratory gases and are also used for swimming, are located behind their legs. The crab normally swims upside down, but its long rigid tail can be used to flip it over if necessary. During mating season, the horseshoe crab migrate to shallow coastal waters, where a male selects a female and clings to her back. The female digs a hole and lays between 60,000 and 120,000 eggs in batches of a few thousand at a time. The male then fertilizes them. Shorebirds eat many of the eggs before they even have a chance to hatch. The horseshoe crab is a true blue blood. It actually bleeds blue, because unlike vertebrates, the crab does not have hemoglobin in their blood, but instead uses hemocyanin to carry oxygen, and because of the copper present, their blood is blue.
Đại家好，歡迎嚟到寵物好精靈，又有我 friend 同埋雞哥。
係你好，剛才咧大家睇咗條短片咧，就係
好多英文啊！
今集嘅主角啦。
係啊，嗱，我哋一陣間咧唔識聽，即係英文，即係唔係咁好嘅朋友，好似我呢啲咧，唔緊要，我哋會有埋中文翻譯俾你哋嘅，係啦。咁
今次個主角咧就唔係異形嚟嘅喎。
好似異形啊！
又係有兩種動物夾埋嘅名啊，好似我哋上次貓頭鷹咁樣。
馬同蟹。
冇錯，但係咁咧就其實佢個學名咧就叫做鱟。鱟冇錯，係遠古海洋節肢動物。
咁個寫法真係好難喎，佢上面一個學字，下邊係個魚字讀後喎。係啊，哇！唔係有邊讀邊。哇，係咯，好難讀啊！真係。咁咧，佢係同蟹咧就冇親戚關係嘅喎。係啊。佢係其實咧就係同蜘蛛啦、蠍子同埋三葉蟲嘅近親嚟嘅。哎呀，三葉蟲咪真係好古老嘅嘢。係啊，三葉蟲已經絕咗種㗎啦。哎呀。嚇！嗱，咁大家可以睇睇馬蹄蟹個身體個結構啊。嗱，佢分開3部分嘅，就有前邊一個好似頭盔咁嘅殼啦，就係頭胸部。咁然後中間就有呈六角形嘅腹部。腹部啊？係啦，六角形邊個六角形啊？即係類似嗰個第2部分，依家睇到中間有個節有條嘢嗰個。冇錯，條嘢就係尾部嚟嘅。係尾部嚟嘅。咁中間嗰一節嗰六角形。係啦。哦。咁佢哋咧就喺個前邊頭腹部嗰度咧，就有一對嘅複眼。複眼。嚇，複眼即係好似蜜蜂啊、烏蠅嗰啲咧，好細好多一粒粒，但係佢得一對。嚇，咁前邊嗰度咧就有又係一對嘅單眼。單眼啊？係啊。佢好多眼喎咁。係啊，佢單眼咧淨係即係感光係對紫外光係敏感嘅啫。哦。就睇唔係即係佢同你單眼嘅時候係唔係俾我嘅色路嚟嘅，係俾紫外光嘅啫。啊，明白。咁咧就佢尾部嗰個劍尾咧就又長又直嘅喎。有冇毒㗎？唔會好似嗰啲魚咁。唔會嚇，唔會傷到人嘅。佢係只係保護自己嘅。保護自己。純粹保護自己。冇毒嘅，淨係一路吉啫。冇攻擊性。冇攻擊性。嚇，咁係要嚟另外一個作用咧，就係保持平衡。咁佢哋係
譬如擱淺嘅時候翻轉身咧，咁佢就靠個尾部嗰度咧，就要嚟支撐翻個身體反翻轉嘅。
係喎，講下我都唔記得咗佢係海洋生物添。
係啊，嚇咁大家可以睇下第2條片啦。嗱，咁大家睇到咧就係一個水族箱裏邊，咁咧呢隻馬蹄蟹，咁佢就依家係好暢泳啦，爬緊，
而家就游啦，哇，游得好似好辛苦喎。
游緊背泳。
背泳咯，係咯，
係
好犀利喎。
咁係用啲腳同埋佢個腹部嗰度係爬，咁跟住就推進自己嘅身體啦。
佢好似唔係好適應呢個水族箱。
可能得一隻啩，所以比較孤單啲。
啲魚都唔係好驚佢，
因為佢係唔係食魚嘅嘛？
唔係食魚，
食死魚，唔係活生生嘅魚。嚇，咁佢最大食糧係應該係蟲啊嗰類。
咁點解人類要食佢哋咧？
其實我都唔知點解。
有得食㗎。
聽講個味道都唔係好味。
係咯，你睇佢撲過嚟，我好驚啊！我唔得啊！我真係覺得好 alien feel。
嗱，可以翻嚟，跟住咧就我哋講下馬蹄蟹進化同埋生物學上面嗰個價值喺邊啦。
聽講佢咧呢個馬蹄蟹咧真係好多年喎，同三葉蟲有得比喎。頭先你話係啊，
佢係4.75億，差唔多5億年前呢個奧陶紀下蟲，
哇！仲要
係侏羅紀啊，
係咯，仲要早過恐龍啊，
再早2億幾年啊，喺地球上出現，但係佢嗰個形態變化咧係冇乜大改變嘅，
冇乜大改變，
咁一路都係咁樣，
即係好似幅圖而家咁樣，
冇錯，
就係幾年前就係咁嘅樣，同而家都係咁樣，
幾億年前已經係咁樣，
都係啲咁嘅手手腳腳，
係啊，冇錯，
好曱甴，有蟹鉗我見到佢，
冇錯，咁咧。就所以佢係有活化石之稱。
活化石，我覺得佢好似啲咩？我哋鼻敏感嗰啲蟲叫咩？蟲蟎蟲，有啲 feel 係啊，都好多腳啊。不過佢係大隻版同海洋生物版。
咁咧依家存活嘅咧就剩翻4種。
4種
嚇，即係4種馬蹄蟹啦。咁第一種咧就係美洲鱟，就喺美洲大西洋沿岸嘅。
西洋嗰邊嘅。
第二種叫中華鱟。
係啊，我成日都見到好似有得食咁，唔知點解行親魚檔都有佢賣㗎喎。
係啊。第三種就南方鱟。
南方鱟。
最尾咧就係圓尾鱟。咁中華鱟、南方鱟、圓尾鱟咧都可以喺亞洲東南亞、日本到越南一帶揾得到嘅。咁而香港咧都有發現過，喺後海灣啦、西貢。南丫島啦，同埋大嶼山嘅沙灘或者泥灘都可以揾到佢哋。其實
我哋游水有冇試過踩到佢哋唔知咧？我好驚啊！
咁通常佢哋就會匿落啲沙裏邊，咁你就唔係咁易踩到。
即係唔會感覺到佢哋喺呢度嘅，因為頭先我見到咧個條片係一堆喺沿岸。
係啊，佢只係繁殖期先至係上咗沙灘嗰度。
哦。咁都安心啲。聽講佢哋咧年幼期咧就會喺潮間帶嘅沙灘同埋泥灘啦生活啦，大咗就會離開咗岸邊㗎啦。咁所以咧大咗咧我就睇唔到，即係唔會踩到佢哋啦。係啦，咁佢就會游到喺20至30米嘅水底係生活嘅。咁我哋係要潛水先見到佢啦。
嗱，咁到咗繁殖期嘅時候咧，咁喺潮漲嘅時候咧，就會爬翻上岸裏邊上面交配嘅，即係好似頭先
嗰條好恐怖好多嗰陣係交配嘅。
咁然後先再游翻落海裏邊嘅。
之後交配完就游翻落海。
生蛋。
有敵人就會潛落沙度。
冇錯。
好有保護性啊，但係冇攻擊性，犀利。
咁最中意咧就食蟲啦，
食蟲。
軟體動物啦。
軟體動物。即係
貝殼啊嗰啲，即係
佢會有個嘢咬開佢哋，跟住
有個鉗嘅，
有鉗，跟住打開入邊，跟住食佢哋啲軟，同埋死魚。
係啦，死魚唔係生嘅。
或者頭先隻魚夠膽游咯，係咯。
咁佢哋喺沙上邊爬咧，就用第一對鉗。
哦，係啊，個化石嗰個鉗嗰個腳我見到啊，咁樣揾嘢食，跟住擺落口。
然後用其他嘅腳咧就擺食物落口。
即係咁樣鉗完，跟住再將喺度啲腳，跟住再執落口。佢口我見到係中間㗎。
中間係腹部嗰度。
係啊，有個白色嘢咁，原來係食緊嘢佢哋。冇
錯啦。
好得意。
咁喺呢個繁殖季節咧，馬蹄蟹咧就會喺潮漲嘅時候啦，就去到沙灘或者泥灘上面揾佢哋伴侶啦。咁雄性嘅咧，如果揾到雌性嘅伴侶之後咧，佢就會用第一對腳，雄性第一對腳咧就係特別有一個扣嘅構造嘅。咁係要嚟鉗住雌性嗰個殼嘅，啱啱好就會即係變咗係鎖實咗。
生出嚟係為咗
係啊，冇錯，
係為咗繁殖。
繁殖冇錯。
OK。
嚇，好。咁通常咧係雌性咧就大隻啲嘅，雄性係細啲嘅。
哦，即係生蛋嗰個係大嘅。係細嗰個喺後邊嘅咧，原來係男嚟嘅。
係啦，雄性。
哇！真係想像唔到咁細隻。
嗱咁當交配完咗之後咧，就雌性咧就會喺適合嘅地方咧就挖啲小窿，
啦，好似龜咁樣挖窿，跟住就係啦，產卵啦，等佢受精啦。咁雄性咧就會將啲分批去產卵，咁總共咧可以生成6萬至12萬粒卵，有冇多得滯咧？
其實因為係佢哋都好多天敵㗎，即係雀仔啊嗰啲咧，咁就會食晒佢啲蛋嘅，咁變咗即係盡量會孵化，即係
佢都係一種食糧嚟嘅，其實都係，因為佢喺食物鏈都好低嘅，所以就生好多好多。
冇錯嚇。
咁佢哋嘅卵聽講話係綠色小球體喎，係咪有圖睇啊？我都想睇下。
好細啊！好細啊！
我哋出下圖嚟睇下點樣？邊一個啊？轉住嗰個就係啊！哇！
咁通常譬如一個高爾夫球咁大咧，已經有4000粒卵㗎啦。
嚇！
係啊！
咁犀利！咁佢要幾多個月先可以孵化成馬蹄蟹？
個幾月咧，咁先孵化出嚟，就係變咗係好細隻嘅馬蹄蟹，即係差唔多手指尾指甲咁大嘅隻。
我都喺度好彩緊啦，好彩佢孵化期間係咁細隻，即係我喺沙灘睇唔到佢哋咯，係啦。
嗱，咁佢嘅成長咧就唔算快嘅，其實嚴格嚟講係比較慢啲添嘅。咁一生之中咧，就起碼要脫殼16次以上。脫殼啊？係啊，要換殼嘅，因為佢身體長大咗，咪舊嗰個咪唔啱，唔夠用咯。
好犀利，好似蛇皮咁，都係要脫皮咁。
所以會脫殼，即係其實好似蟹啊咁。
蟹都會脫殼。
都會㗎。
哇！犀利！我而家先知㗎咋。咁佢哋話要脫殼16次。起
碼。
咁1年1次定係點樣計啊？
佢就唔係1年1次嘅。譬如佢細嘅時候，生長快嘅時候就需要脫殼。
睇翻佢自己生長食唔食得多嘢，健唔健康。
就唔係話1年1次咁樣嘅。不如我哋又去片睇下。
好啊。係咪脫殼片？
係。水族缸裏邊啦。係。咁呢一個已經係一隻馬蹄蟹嚟㗎啦。係。咁已經開始脫殼，脫咗頭部。
佢褪頭喎，我見到佢褪咗出嚟。
深色嗰個已經係新嗰個大啲嘅殼嚟㗎。咁喺頂嗰個佢係舊嗰個。
哎呀，係啊，退緊出嚟啦。
你側邊有人幫手添喎。係啊。
Look at him. He's definitely the little one's pushing right on him.
咁嗰個殼就唔係死咗，只係退咗個殼擺咗喺度啫。
就唔用㗎啦，舊嗰個。
唔會有新嘅攞嚟用嗰啲嘅。
我唔會。
唔會個殼。OK。我以為寄居蟹即係攞人哋個殼嚟寄居咁。
咁或者真係有啲寄居蟹攞咗嚟。
And it's working.
咁慢慢就會成隻咁就換咗殼啦。
呢個過程都需時㗎喎，睇嚟。
應該都要幾耐。嗱，咁經過9年至12年嘅時間先至成長，算係一個成熟嘅馬蹄蟹。
即係先係可以交配嘅。去12年咁先可以成熟。咁由粒卵去到變成依隻馬蹄蟹嘅機會其實係1/1000喎。係
啊，好低機會，所以佢要生好多蛋先，好多卵先。
咁佢真係好多天敵喎。
係啊，
即係魚又會食佢啦，雀仔又會食佢，咁又會唔見咗。仲有人係，但係人係食大佢大個咗之後嘅，係啊，我唔會食噶，我唔夠膽食噶，見到佢已經覺得你唔好喺度爬啦，跟住啲人就會反轉佢，佢就爬唔到噶咯喎，但係仲核突，係。但係佢有條尾可以踩翻自己，反翻轉嘅。係咯，但係我未見佢成功過咯，俾人捉住嗰啲。嗱，咁除咗係俾呢個喺食物鏈度提供食物，即係俾其他 食物鏈俾其他做食物嘅時候。咁
馬蹄蟹咧有一個好緊要嘅作用嘅，一個貢獻嚟嘅。
我頭先有睇到一開始嗰段片，嚇死我啊！原來佢哋嘅血係藍色㗎。
係啊，真係藍色，真係
藍血人啊，
貴族嚟嘅。係
咯，英國貴族嚟嘅。
點解會係藍色嘅？係因為佢哋血裏邊有呢個銅離子啊。
銅離子。
血清蛋白。咁如果係氧化咗之後，即係暴露咗喺空氣裏邊咧，就會呈藍色嘅。即係好，正如我哋人血咧，就會係紅色嘅。係啦。紅色因為我哋有鐵質。
有鐵質。咁佢有銅，所以就係藍色。
嚇！咁係將佢哋嘅血液即係提取之後咧，就可以叫做成一種叫後視劑。後視劑係？後視劑係有咩作用咧？就係可以快速同埋準確地檢測有冇細菌產生嘅毒素。哇！咁喺廣泛應用喺醫藥測試嗰度㗎。咁係睇佢有冇受到污染咁樣嘅。係啊。咁即係其實藍血都唔係咁好嘅啫喎。如果我係藍血，我咪會俾人走去做呢啲。咁佢哋依家就唔係捉佢嚟抽晒嗰啲血嘅，就係抽一部分嘅啫。抽一部分，然後再放翻生嘅。哦，咁都好喎。就唔係殺死佢嘅，即係唔係抽晒跟住死咗。係，我都好驚抽晒，咁咪絕種佢史前生物嚟嘅喎，仲要俾人食。我哋香港俾食佢咯。嗱，咁就唔係咁，依家係已經佢哋嘅血咧係差唔多係1公升係15,000蚊美金。1公升好少啫喎，15,000蚊美金。係啊。嗱，香港人啊，大家去到嗰啲咩嗰啲攤檔啊，嗰個咩西貢嗰啲咧，係啦，最主要我喺西貢見到佢哋嗱抽佢嘅血，算啦，唔好食佢哋。係啊，千祈唔好食，因為佢哋嗱頭先講過咧，由生長佢粒卵係啦，要成差唔多12年啊，9至12年啊，先可以去演化咗成個過程，跟住俾人抽血嚟提取呢啲咁嘅為我哋着想嘅嗱驗菌劑啊，又同埋呢啲咁樣嘅藥物啊，真係好大貢獻啊！係啊，所以咧就即係盡量唔好食啦，因為你如果食咗佢咧，咁另外啲卵又係啦嚇，咁卵係佢會儲藏喺邊度咧？就係嗰個頭腹部前面個頭個殼個腹部前面嗰度。咁嗰度就有成幾萬㗎喎。係啊。好細粒，雌性嘅卵就係擺咗喺嗰度嘅，跟住就埋喺沙度，等佢慢慢孵成一粒好細睇唔到嘅嘢。跟住大咗之後咧，大概幾個月之後就會游去深水區域生存。真係要潛水睇下見唔見到佢哋。咁咧就今集就介紹咗馬蹄蟹咯喎。咁嚟緊我哋仲有啲咩會介紹咧？哇！嚟緊介紹佢真係勁啦！我上次見過啊，係啦，大家睇唔睇到呢一個係咩嚟嘅咧？應該睇唔到啦。係呢個咧係我讀俾佢哋聽啦，中華白海豚同埋江豚啊。好，咁留意我哋下一集。留意我哋下一集中華白海豚啊！我哋下一集再見啦。我哋片尾仲有片㗎。係啊。
They might look like rocks with tails or messed up giant bugs, but horseshoe crabs are super old, super cool, and they deserve your respect. They may have already saved your life. First of all, They aren't crabs. They're members of their very own family of arthropods including insects, arachnids, and crustaceans, known as Limulidae, and there are only 4 species of them in the world. They're more closely related to arachnids like spiders and scorpions than anything else, but really, they're their own deal. They're also mega ancient. The oldest horseshoe crab fossil we've found is around 450 million years old. That means they have survived virtually unchanged for nearly 500 million years, outliving pretty much anything else. These guys are survivors. So what makes them so tough? Well, part of that is their amazing blood. For one thing, it's blue. Baby blue. Our blood is red because the substance it uses to ferry oxygen around, called hemoglobin, contains iron, but horseshoe crabs use hemocyanin, which is copper-based. So just like iron turns red when it oxidizes, when copper meets oxygen, it turns blue. But that's not even half of what makes horseshoe crab blood so cool. So seawater is chock full of bacteria, and unlike mammals, horseshoe crabs don't really have an immune system, no infection-fighting white blood cells at all. So if they get a crack in their shell, all that bacteria just gets into their bodies and could wreak all kinds of havoc. What they do have is a glorious chemical found only in their blood cells that binds to and inactivates unwanted bacteria, viruses, and fungi. When the blood cells sense some bad guy invaders, they release a protein called coagulogen that forms a gooey barrier around the infecting agents, preventing their spread. That clot of gooiness actually creates a physical barrier, sealing up the wound and preventing further infection. It's an amazing internal defense mechanism. Humans, we have no such ability, so for the past 50 years, we've been stealing it from the horseshoe crabs. Ever since American physician Frederick Bang discovered the weird power of horseshoe crab blood in the 1960s, these ancient sea creatures have played an essential yet largely unknown role in human medical treatment. If you have ever received any kind of drug or vaccine through injection, it's because these crabs made sure that that injection was bacteria-free. The whole thing starts when horseshoe crabs are collected from the wild, transported to one of only 5 production labs in the world, and then rigged up for a blood drive. Needles are inserted around the heart, and up to 30% of the animal's blood is removed. This stuff is liquid gold. It can go for $15,000 a liter. From there, scientists extract the coagulogen from the blood cells and use it to test solutions that are used in injectable drugs and vaccines. If the crab blood extract finds unwanted bacteria in the solution, it immobilizes it in a gooey clot. So if your sample doesn't form any clots, you know that it's bacteria-free and safe for human use. This simple procedure, called the LAL, or Limulus amoebocyte lysate test, is nearly instantaneous, and no other test works as well. As for the crabs themselves, most seem to bounce back several days after being released back into the wild, but some folks are concerned that the bloodletting weakens them more than we think. So LAL manufacturers tend to only collect blood once a year to ensure that they're not double dipping on the same crabs, and research is being done to come up with a synthetic alternative so that we can eventually leave them alone. Until then, next time you get a shot, give thanks to all those old horseshoe crabs who made your good health and your sore arm possible. Thanks for watching.